So this is October 2025 paper, Unit 1. Question number 1 says atomic numbers and mass numbers are used to identify isotopes. What is the mass number of the isotope? Of course, the mass number is this one. That is going to be 84, isn't it? This is going to be the mass number, right? So the lower number is the proton number. Like the smaller number is the proton number and the larger number is the mass number. So no need to calculate each and everything. So C is your answer, right? Which element has the atomic number 15 and mass number 31? So of course, if you can see the periodic table, so you will see that the proton number for phosphorus is 15 and the mass number for phosphorus is 31. So that's why option B is correct. Okay. What is the number of electrons in the selenide ion? Selenide is 2 minus, since you can see the proton number, that is 34. 34, 34 and then plus 2. 34 and then plus 2 would be equal to 36. So how many number of electrons? So I can say 36. So B is your like correct option. Okay. Mass spectrometry is used to analyze samples of elements and molecules. What is used to accelerate ions in a mass spectrometer? If you remember when we used to draw the ray diagram, so I told you that this is the filament which is ejecting high energetic electrons when the sample enters over there. Of course, these high energetic electrons are going to remove electron from the outer shell of the sample and cations are formed. And in the way of this one, we have put like the uh, negative disk. This was negative disk. Of course, it's going to attract the cation. So what does it mean if it's going to attract the cation? It means that this plate is going to accelerate the positive ions, right? So that's why electric field is the one which can accelerate the ions, right? Then a sample of boron contains 20.6% B10 and 79.4% B11. So there are two isotopes of boron. What is the relative atomic mass? Means that they're asking AR. So if you remember, what was the formula for AR? Isotopic mass multiplied by the percent abundance. Simple. So divided by the total abundance. So I got 10.79 means C is correct. Okay. Bromine only has the two isotopes, that is Br79 and Br81. A pure sample of elemental bromine, that is a molecular bromine, was analyzed in a mass spectrometer. Why did the mass spectrum have a small peak with mass to charge ratio 80? Option number A, an isotope with a mass of 80 was formed in the spectrometer. Uh, yeah, it was formed. Okay. The thing is that, they are saying have a small peak, have a small peak. So this is not the correct answer for the given statement. Okay. There was contamination. No, 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 no. Due to the contamination, we won't see the small peak, by the way, remember. Ions can form with a 2 plus charge. Yeah, this is not common thing that the bromine is going to have a plus one, sorry, plus 2 charge, bromine forms plus 1. And if it would be forming plus 2, because if you can see the mass spectrum, so we see mass to charge ratio versus the percent abundance, right? Mass to charge ratio means what? Let's suppose the sum of these two, like I'm talking about this bromine molecule, what's the mass of this one? What's the mass of this one? Of course, 160. So 160 divided by 1 is 160, isn't it? What is one? It's the charge. It's the charge of bromine. And where it comes from, of course, when bromine enters in a mass spectrometer. So outer electron is removed. So that's why Br plus is formed. But they are saying 80. 80 means that when bromine would be having a plus 2 charge, so 160 by 2 would be giving you 80. So that's why C is correct. Okay. Um, okay. And then they are saying an organic compound contains this percent carbon, this much hydrogen, this much oxygen by mass. The molar mass of this compound is going to be 90.00, 90.0 grams per mole. So what is the empirical formula? So this is the like like basic question, uh, we generally write the percentage of carbon, then percentage of hydrogen, then percentage of oxygen. So we got the mole. Then what we used to do, we have to divide this with the smallest number. Of course, the smaller number is 2.225. So I have divided these whole things by 2.225. Then I got the simple mole ratio. That's why the answer is C2H5O. This is baby question, it's a baby question. It's very easy paper as compared to the other papers. Strontium nitrate. Okay. Ionic equation. What's the concept of ionic equation? What we do, we have to break down the aqueous thing. No need to break down the solid, no need to break down the gas, no need to break down the liquids only. We have to break down the aqueous things. Okay, so this is aqueous. So nitrate is cancelled by the nitrate. Of course, I'm not supposed to break down this one. I'm not supposed to break down this one. And I'm not supposed to break down this one. So it would remain same. So what's the option in which it's the same? Of course, C and D, you can see. So then we have to select which option is correct. So this is the common thing, that this was the aqueous compound and it needs to break down. So after breaking down, I would be getting this one because nitrate is cancelled by the nitrate. That's why option C is correct, isn't it? Why option D is incorrect? Because nitric acid is not dissociated. How is that possible? Despite that this is going to be aqueous, it is supposed to be breakdown, isn't it? What is the percentage atom economy by mass for this preparation of strontium nitrate? So means that what's the formula for the percentage atom economy? The mass of our desired substance, that is strontium nitrate, divided by the total mass of the product side. So we have to like put the MR. Okay, we have to put the MR. So after putting the MR, you would be getting your answer. Like for strontium nitrate, what's the MR? It's going to be 211.63 divided by 211.63 plus carbon dioxide is 44, water is 18 times 100. Okay, let me add them up. 211.63 plus 44 plus 18. Is the equation balanced? Yeah, this is balanced. Okay. So this is going to be 273. This is going to be 273.63 and times 100, right? So 211.63 divided by 273.63 multiplied by 100 is going to give you 77.3. So option C is correct. Which isoelectronic ion? Isoelectronic means that when the number of electrons are same. Iso means same, like isotopes, like isomer. So isoelectronic. Of course, isoelectron all has the same electrons. Calcium is 20 minus 2 is 18. Chlorine is 17 plus 118. Potassium is 19 minus 118. Sulfur is 16 plus 2 is 18. So they are saying which has the largest atomic radius. So we have a concept, the size of anion is greater than the size of cation. Of course, option A and C is a nonsense option. So we have to see B and D. These are anions that are going to have a negative charge. Okay, so I'll be looking at the anion. I'll be looking at the anion. Remember, right? So so then I have to see chloride or sulfide, like which is correct. Across the period, size decreases. Across the period, size, sorry, yeah, across the period size decreases. So if you can see period 3, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, and then chlorine. Of course, chlorine would be smaller, sulfur would be larger. So they're asking the largest. That's why option D is correct. Okay. zero point 0.1 mole of is sodium nitrate. Okay, this is the volume of a solution is given to you. Then they are asking the concentration in grams per decimeter cube. What I did, I have just found the concentration in mole per decimeter cube. How? This is the mole. I have just converted this cm cube into the dm cube after dividing by 1000. So I got the concentration in mole per dm cube, that is going to be 0.4. But they are asking the concentration in grams per decimeter cube, isn't it? They are asking the concentration in grams per decimeter cube. So what I am supposed to do, I have to convert this mole into the mass. This mole into the mass. So yeah, like in grams basically. So zero point 0.4 multiplied by 85.4 multiplied by 85, that's the MR of sodium nitrate. So I got 34.0. That's why the answer D is correct. Easy, right? Which of the giant lattices of carbon atoms contain flat hexagonal rings? If you remember the structure of graphite, and by the way, graphene is a part of graphite because we have taken a layer of graphite, so this is known as graphene. So if you can see the structure of graphite, so you will see hexagonal rings which are arranged in a layered form. So it has a hexagonal ring. So if the graphene is a part of graphite, so of course the structure would be the same. That's why D for doctor is correct because both are going to have a hexagonal ring structure. Okay. And then the first ionization energy for hydrogen is 1312 kilojoules per mole. What is the ionization energy in joules? Joules. So what I did, I have just converted this into the joules. You know, I have just multiply it by 1000 to convert it from kilojoules to joule. Kilo means 1000. And then they are asking per atom. Per atom. So what I did, 1312 kilojoules is equal to 1 mole. Isn't it? Per mole means 1 mole. Per mole means, and 1 mole is equal to 6.02. We know that, we know that 1 mole of any substance is equal to this much atoms. So what I did, in the like like despite I'm writing 1 mole, I can also write 6.02 times 10 to the power 23 atoms. They are the same thing because 1 mole has this much atoms. Okay, so if they are asking per atom of hydrogen, like I have to find out the energy in one atom. So I told that this is X. After cross multiplication, I got this answer. That's it. Right? Okay. Simple. Which molecule is polar? Which molecule is polar? So if you know the concept of dipole moment, you can see BeCl2. The dipole moments are cancelled. And if you can see the structure for NCl3, it has a lone pair of electron. And if you can see the structure of CCl4, tetrahedral, and if you can see the structure of PCl5, that is trigonal bipyramidal, you know, they are going to be cancelled. The overall effect is cancelled. But due to the presence of lone pair, the dipole is not equal to zero. The dipole is not equal to zero, so that's why this is going to be polar. That's why this is going to be polar, remember. So that's the concept for polar and a non-polar. Okay. So if the compound has a dipole that are going to cancel each other, okay, so I would say that it's going to be non-polar. And then if the dipoles are not canceling each other, so I would say that's going to be polar. Okay. For this, you need to know the structures, like which is tetrahedral, which is linear, which is trigonal planar, which is trigonal bipyramidal, like which is bend shape. Because other than this, you would not be able to tell in which structure that the dipole is going to cancel each other. So, like if you remember the theory when we were discussing electron pair repulsion, like like if we have four bond pairs and zero lone pair, so that's going to be tetrahedral. And if I have three bond pair and zero lone pair, so that's going to be trigonal planar. So that's what about like I'm talking about. Okay. Zinc has electrons in sp and d orbitals. How many electrons in total does zinc have in a p orbital? So I have to write down the electronic configuration first. When I did electronic configuration, I saw that there are two p's. There are two p's. One is 2p and another one is 3p. Then what I did, I have to just count the total number of electrons which are present in a p orbital. So it's 12. That's why option A is correct. Yeah, it's a baby paper, isn't it? It's a very paper, unexpected paper. Then a sample of cerium. They have given you the mass of cerium. They have given you the mass of oxygen. The same thing as you did in the previous classes, right? So what I did, I have just found the mole first, then divided with the atomic masses of cerium and oxygen. Then I got the moles. Then again the same criteria, same like in a same paper, they have asked the two same questions at the same formula, isn't it? So then we have to divide this number with the smaller number. So I have divided these two values with the smaller number. So then I got 1 and 2. So that's why the formula is CEO2. Okay, again, this is very easy. Which compound can only be named using the easy naming system and not using the cis and trans naming system. Cis and trans is used when the groups are same. Let me make it clear. Let me make it a very crystal clear that cis trans is used when the groups are same. Remember, okay, in this structure, the groups are same, they are same, they are same. But in A, nothing is same. So that's why we have to opt E and Z isomerism rather than cis trans isomerism. Okay, hopefully you understood this, right? Free radical substitution is the mechanism of the reaction between methane and chlorine. Like I always say in initiation, the radicals are present in the product side. Let me write it down. In initiation, this is very important, in initiation, the radicals are present on right hand side. In propagation, the radicals are present on left and right. And in termination, the radicals are present in the left hand side. So then what they are asking, oh, okay, which drawing of curly arrows shows initiation? Of course, chlorine is a non-polar molecule. When the sunlight would strike on the bond of chlorine, like the covalent bond, so there would be homolytic fission. There would be homolytic fission. There would be homo means like equal distribution of electron. And you know this bond means this electron is for this chlorine and this electron is for this chlorine. Of course, when the bond will be breaking down, it would be taking away its electron and it would be taking away its electron. I have to draw the single-headed arrow because it's due to the one electron. If two electrons are going from one place to another place, then we have to make a full arrow. These two heads are going to represent the two electrons. And if you can see the single one, so this is going to be only one electron, isn't it? That's why option A is correct. Which equation is not a possible propagation? Possible. To answer this question, to answer this question, you must have a clear concept. You must have a clear concept of free radical substitution reaction. When we were doing that reaction, so we never saw that the radical of hydrogen was formed. No, it's not possible even, isn't it? Because let me tell you, this is CH4. This is CH4. When it reacts with radical, it will attack on this hydrogen to form HCl, and the CH3 radical was formed like this one, isn't it? So that's the only option that is not possible even in all steps. Let's say if I'm going to work on ethane, 6 hydrogens, oh my God, 1 hydrogen is removed in 2 steps. So you will see in all steps, you will never see that the radical of hydrogen is formed. No, never, impossible. Okay. You will see this one, you will see this one, you will see this one, but you won't see this one. You can try. We did the theoretical portion, right? So, and if you are not going to understand, so then you can comment, then I will be answering you. Okay, I will be sending you the link. What differentiates a termination step from a propagation? Yeah, termination, the radicals are made. The new radicals are not going to form, isn't it? The new radicals are not going to form. But in a propagation step, the radicals are formed. Radical, 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 because this is propagation. Simple one, this is propagation, right? So that's why option C is correct. Because in a termination, no free radicals are formed. Even in a termination step, we are just going to eliminate the radicals. Okay. Um, so that's all for like the section A. Okay.